the curves y equals root x and y equals x. The region in quadrant 1 between y equals root x and y equals x. So we got a full house. This is the first time all we've got a full house. I've missed our full BC family here. We've literally had the only full day this week, and tomorrow we're gonna be down 2. Okay.
Yeah, I'm doing a screencast.
No wonder, this whole week I just felt so off balance, like we've never had our whole people.
Wait, what do you want us to
Did you
describe?
say
The distance between?
No, I want a sketch of the area between y equals root x and y equals 1 only in quadrant 1. I want you to sketch the area between y equals root x and y equals x in quadrant 1. Y equals x and y equals root x. Yes. Y equals root x. Shade the area between y equals root x and y equals x in quadrant 1. Okay. Just the area between these two curves. I have to say, and Kate's not here, no wonder. This week is such an odd week. I have not had all of you. I have to say, I want to give you lots of props, you all, class. I don't know, not you. I'm just kidding, Martin. I have to say, I've been so impressed with the way we have just really worked together, even though at certain points we've not come to the same place. So I really like kind of our teamwork here. Do you agree?
Yeah.
Okay. Then I want you to try to the best of your ability to sketch the solid that results if we do a revolution about the y-axis. Just we're just sketching. I'm not doing any solving. You're just sketching it.
Wait, are we sketching?
Sketch to the best of your ability.
Around
The
the-
solid of space that results.
Wait. It'd be like,
I need like Play-Doh.
Isn't it like a hollow cone type
it'd be like
thing?
right?
Maybe try
Yeah,
to
it'd be like a
describe
cone.
it.
It'd be some kind of like some
like a cone,
like
like a
funnel,
paper
right?
cone. It's like big. That's how they
yeah, it'd make like a cone. It would,
Yeah.
But it would be like this.
but it'd have some like
It would be
weird
like
shape.
this.
On the inside, it's
Like an hourglass? Like that.
Okay, but how do you draw this on a graph?
Wouldn't it kind of be like that? Or wouldn't it be like this? It'd be like it'd go like this, but it'd be going in like that. Yeah. But like, wouldn't it be
Interesting.
hollow in the middle?
Yeah.
So it'd be some like kind of like coney looking thing.
No, but like it's like
Yeah.
So
Interesting.
on the outs, if you were to look at externally, it looks like a what?
Cone.
Cone. Okay, so let's just try our best, and here's what we're gonna do. Because you know what I've said over and over again is, with these volumes and area questions, particularly as they get more involved, it is always to your advantage to take a few minutes and make the sketch. It will avoid almost every single careless mistake that I
Yeah.
see with these kinds of questions. Here is how I try and convey this. You get better at this. And really what happens is, what you'll end up doing is eventually you will just need to sketch just what you need to visualize it. Here's what I tend to do. I like to make it clear. Do you agree it's a circular opening at the top?
Yeah.
All right. Okay, and you know it's gonna come out this way. Remember what these questions were. We're asking ourselves about the volume of the solid of revolution. I'm not asking, and what's really dangerous is when we say volume, we want to say, oh, the volume of liquid this cup holds, so to speak. I want to figure out the volume of like the clay involved in making this solid part. Does that make sense?
Wait.
Okay? Because these are, after all, volumes of solids of revolution. I'm not asking for the volume of water a vessel can hold. It's the volume that results from this area when I revolve. Like that space is gonna occupy a certain space around. That's the volume I want. The volume of the solid part.
So whenever you revolve it around the y-axis, are you going into the z too? So you're like making it.
I think this is what Jason was asking too. Like I think you're saying is when you revolve it, we leave just 2 dimensions. We enter like a 3-dimensional world. That's not the z-axis, which is a different thing. So all I want you to think to yourself right now is that the result of revolving a 2-dimensional shape gives you a 3-dimensional entity. Do you pop out in the z direction if you want to call z direction? You certainly can call it that. But the reason why I was very particular about that is because if or when you take multi-variable calculus next year, the two are not the same idea, which is kind of what Jason and I were talking about yesterday. Okay? Can you visualize what this solid is? Okay.
Yeah.
I am going to slice into this in this direction. If I take cross sections, I'm going to attempt to draw a cross section. I'm going to draw a cross section right here, and I think you probably all agree that the cross section would in fact be circular, right?
Yeah.
But I am just going to, yesterday, I shaded in the part of the cross section that was embedded in the solid clay, so to speak. It is not the entire circle. It's just the circle's what? It's like a ring, and here's where it's going to be like the first time we do this method, it's going to be important that you make your drawing readable. So what I tend to do is I tend to do this, and I just shade in really clearly that it's that part that is enmeshed in the solid. You know what I mean? Okay?
Okay, so you're not trying to find the volume of the inner piece?
No, these are called volumes of solids of revolution. I want the volume of the solid material.
So the shaded area.
Yes. So, and I'm going to just go ahead and draw a couple of these. I'm going to draw 2 cross sections. Oh, and Jason and Gary too. I'm in I told you I was going to make you a screencast where I talk about the questions you both had yesterday. It's still in progress, but I haven't forgotten, I promise. No, we did not. Drill.
I'm sorry.
Okay.
What question did you ask?
All right. Those are my cross sections. And now what I'm going to do is I'm going to draw just like yesterday. First time through, we want to really make sure we can see this. What I'm going to do is I'm going to draw one of those cross sections as if I were looking at it frontally, like this. So I'm going to go down here and take one of these cross sections just so I can look at it clearly. The major difference is that now I'm looking at a cross section where yesterday, or air quote yesterday, we shaded the whole circle in because the whole circle was embedded in the, here's that phrase again, the solid of revolution. Not asking about how much water it would hold, it's the solid of revolution. All right, let me know if I should pause. You know, this is our big idea, and I fully agree. I mean, you remember those of you who did this last year. This is a big lesson, right? It was like pretty huge, it was a big milestone, put it that way. The volume stuff was a big milestone. All right, it's a pretty big milestone. Eyeball? Oh yeah, that's like an eyeball. How do we? So in math speak, we used filled in circle last time, which is called a disc. We call this an eyeball, but or donut. In calculus speak, this is called a washer.
Oh, actually.
Okay.
Washer.
Washer
Stage root.
I feel like math takes away the fun. It takes something that's like exciting, like a donut. It's like crushed up on itself.
It just kills the joy.
Yeah.
Kills joy, like a joke.
Oh, washers are pretty fun.
Yesterday when we were doing the disc, didn't we use like
area
Yeah.
and add up the areas. But
What
wouldn't that
was the
result
other one?
in
I saw this
volume?
triangle method.
But wouldn't that result in volume that's like not the volume
Huh?
that would be the volume of space like in between?
One is big R squared, mine is little
That's
R
a
squared.
great question. Okay, did you
And one is
hear
the
that?
whole.
Ask it again. That's a really good question. I'm gonna help you. What Jabril just said was, in our last class, we talked about adding up the area of all those circular cross sections, and that would equal the volume of space inside. Right? Do you understand what I'm saying? When the, so here's another way of asking that question. When the cross section are disks, okay, which is the filled in circle, true or false? Only when the cross sections are disks, true or false, the volume you get is the same thing as the volume of water that thing would hold if it were hollow inside. True or false?
True.
That is true. Is the same thing going to happen here? Well, let's just see. That's where you're seeing some disconnect. So just hold on, okay? This is a washer cross section. What we did last class was we just figured out what is the area of the portion of each cross section embedded in the solid or evolution. You see that? Would you agree, everyone, that the area of the shaded is pi r squared big circle minus pi r squared little circle? Agreed?
Mhm.
I'm gonna go over here and do this. Let's just, on this washer cross section, let's call this R sub L with large radius. And let's call this over here, R sub S with small radius.
Who's betting on? Because like it's not, they're not just two lines, one's like curved,
I know.
so then like the radius.
Yes, I know, just wait, I promise you, I will never leave you dangling.
Change at the rate of like.
I know, I just, wait. I know, I will never leave you hanging, okay? What I wrote here was, you agree, the area here is just pi r sub L squared minus pi r sub S squared. Walter, I love your brain, I don't want it meshed in the carpet fibers. And I don't want that happening, okay? It's a pet peeve, I hear, okay? Everyone okay so far?
Yeah.
Walk with me over here. Let's go to the solid. The critical body parts, we always draw them to the curve, not its image. That will always help you. So go over here. Let's draw R sub L. Right? That's R sub L. Here is R sub S. This is R sub L. First time through, I go through very methodically. R sub S. Okay, just laying the setting the stage for what's to come. Okay, so let's talk now. In this particular case, with these particular cross sections, we are adding up cross sections that are stacked over an interval of y or an interval of x.
Why?
So we know this volume is going to be a summation of infinite things over an interval of y. Okay, we're going to get there in just a minute. Now, let's talk about this. The dummy is y. See, I'm going about this very carefully. The dummy is y. The dummy is y because the cross sections are stacked over an interval of y. What is the interval of y over which those cross sections are stacked? From y equals blank to y equals blank. What's the blank?
0, 1.
Y equals 0 to y equals 1.
Wait, why?
Because the interval of y
Yeah.
over which the cross sections are stacked
Mm-hmm.
are from y equals 0. They intersect at
Oh, where they intersect. Okay.
Yeah.
Gotcha.
1 comma 1. Tell me what the integrand is going to be based on what you know from last class. Tell me in words. The integrand is going to be the blank.
The rate.
The integrand is going to be Arjun?
It's gonna be the area of one cross section.
It's going to be the area of one cross section. So let's build it together. Ready? I'm going to factor the pi out. I always factor pi out. I always factor pi out. Equals pi. All right. Big radius. Big radius. Do you see it? Big radius is right here. It goes from the line, the y-axis, all the way out to the green curve. What is that green curve?
Y equals X.
It's y equals x, or it's x equals y. Which one do you want to call it?
Y.
X
X
equals
is Y.
So we're going to put in here for outer radius.
Y.
Y.
Y. Y,
Square.
dummy. That's the outer radius. Y squared. Outer radius squared. Outer radius squared.
Okay.
Oh.
Got it? Outer radius squared is always on this green line. Outer radius squared. Minus, and we'll fix it in a minute, inner radius. The inner radius goes to this curve.
So it's
It
root
goes to
X.
this curve.
Y squared.
Y squared.
Y
Square.
Y squared.
Y to the
What?
Y to the 4.
Y to the 4.
What is it?
Y to the fourth is squared, squared.
It's squared,
you
squared.
multiply.
Y to the fourth, and then here's where I'm gonna be very picky. I want this parenthesis, the dy. That's the volume. Whoop. That's the volume. Okay? So the thing here is, are there any questions before we move on?
Oh.
Wouldn't it be easier to do it next?
Do what one?
Wouldn't it be easier to do this next because then we can just have sideways
Holy moly, do what in X?
volume?
Of this?
Yeah.
So,
Would it be the same?
Low key.
No, Arjun,
not be the
no.
same. If you wanna think about cross sections stacked over integrals X,
Oh, yeah, okay.
does it make sense?
Because it's not
New
this way,
problem.
not this way.
You need a new piece of, yes, Nicole.
So like the reason you have to do like the two radiuses minus each other is because like when you rotate it, like only part of the like the solid's like in the circle. But yesterday, like all of it was. But like, what kind of pictures were we looking at yesterday then?
So when we
What
revolved
were we
it,
revol?
the
Yeah.
solid occupied, like there was no hollow.
Oh, okay.
So drill,
It was like
whatever this answer is,
solid, like,
this is gonna
filled
be
in.
equal
Oh,
to
okay.
the amount of water pulled, yes or no?
No.
This is just the amount of like clay involved in the solid part.
it's like
That's the
volume
difference,
versus
Nicole.
like
Did you catch
surface
that?
area.
Okay. Yeah.
That's a really good,
Okay.
what did you just say to her?
I said it's like volume versus like the surface area, kind of.
It's not surface.
Yeah, but when we did it
Sort of,
last time,
kind
we
of.
got the surface area.
No,
But I
you
feel
got the
like-
whole volume.
I mean,
No, it's like
when we did
solid
last
volume
time, we
versus
got
like
the
hollow
area.
volume. No, last time you
No,
got.
you did the same
No,
thing
Jibril,
last time.
Jibril.
Last time.
Volume.
Bro.
Think about like last time we did it, it was like that whole thing was filled in.
Yeah, let's
But
like.
we
What
went
was
the
that?
same, we're not.
But I don't know why that was filled in when it was just like a line just kind of being reciprocal.
Oh, because it
And
touched
why would-
it touched the axis you were going on.
Yeah,
Because
When it
the
doesn't
air,
touch
because it was against the axis, so there
Mm-hmm.
was no space for there to be like empty space in the middle.
Wait.
Because the area you were finding was the whole.
Because it touches the
right?
Oh,
And I would
big G. Okay, wait.
This last night.
Alright.
That's what happened last night. The difference now is that, so I think what they're saying is
Oh.
like, the axis we revolved again around last night, you just say it touched the whole area, they're saying it touches the whole area,
Yeah,
okay? Now, here's what you're going to do.
it's clear.
New piece of space, okay? All I want is the integral expression. I'm going backward. I'm going backward, go backward. Ooh,
Yeah.
Yeah.
Or
Yes.
that was like
How?
everything
Like
filled
how
in.
do you count
Yeah.
the curvature of square root of x though?
How do I count for curvature of square root of x? Well, because this is just x equals y squared.
Oh wait, yeah, no. Yeah.
It's okay, it's okay, it's okay. Ready?
I know.
Okay, Jibril. That was little unnecessary.
You know how that you see Chicago?
No.
You see Chicago.
No, it had
Oh
nothing to
my
do with
gosh.
you. Sorry.
Okay.
I don't know what
and a D, por favor.
You missed a lot.
Okay? This is here. Oh, thank you, Walter and Jason.
Such a good student.
I'm just not getting up.
Oh, Jason just turned around. Seems like I don't have the energy to move right now.
Here's what we're doing. So this is, if you want to know, like, how can I make this a multi-part question? All right.
I really wasn't, I wasn't here.
What did you just say, Arjun?
I think easier would be better.
What did you just say?
He said easier would be better.
Here's how I make this a multi-part question. Part A. So these are three, set up an integral that would describe blank, okay? Part A, set up an integral, I'll say it first and we'll write it, you can write down whatever you want. Part A is set up an integral expression that describes the shaded area. That's A. Part B, set up an integral expression that describes the volume as a result of that relation. Okay? Part C, set up an integral expression that would describe the volume as a result of this revolution. Okay? Three different questions. So A, I want the area shaded as an integral expression. Part B, I want the volume of the solid as a result of an x-axis revolution. That's that one. And here is part C. I want the volume of the solid as a result of a y-axis revolution. Okay. Arjun, I feel badly. Did I hurt your feelings before when I was saying no, not you? Because I was just kidding, Arjun. I wasn't saying not you. I was just kidding, Arjun.
He's really traumatized, but I think he can make it.
I don't think the head has.
I think no, but I think Arjun, our relationship goes back so far that I think that it would have been more, it would take more for me to hurt your feelings. I was just kidding. But the fact that I made you be a butt of the joke, I feel badly now.
But what
He's
about,
like profusely apologizing and like,
It's a lot.
for Walter.
Yeah.
No sympathy for Walter.
Oh, Walter!
What a class. What a
It's
class.
all good.
this
You
class.
are a great class. You are a great class. I hope it also shows that I thoroughly enjoy you.
Thoroughly.
Thoroughly. Are we done?
No.
No.
I thought you knew this class. I thought you knew me. I have no idea. Oh wait, I just need to switch it up.
Walter!
It happens. Like it's right on the money. He's on time. We have with Vlad.
I know, but we're not thinking about Latin.
But he gives me
Great.
He gives me the 15-minute like no.
Walter! Stop that. Don't be such an opportunist in that way. Just because things don't have an immediate point quantitative metric of gratification does not mean it's exquisite nonetheless.
Say what now?
What?
What?
Okay, I don't really know which one's in terms of x and which one's in terms of y.
Maybe.
Ish.
I think what I'd like to do for B
What is 4 times
and for
2?
C, what I might do, I'd like you to do this, please. For part B and C, I want you to sketch the solid. Okay, do it because it will avoid all things.
Yes.
All
Like,
things.
do
It would avoid doing the work.
Well, you know what I mean. Okay,
I don't know how to look at
okay. If I revolve that area about the x-axis, what results something that looks like this. So what I'm doing here, and so just as an example, the reason why I thought of this to do is because I wanted to pick up on the very question that Nicole and Nicole were asking, which were when, under what situations and circumstance. Okay, and if you, let me tell you, if you take the 20 seconds tops to draw the picture, it avoids almost all Carol's mistakes in questions like this.
How did that, wait, what did you do in B? How did you flip the picture like that? Why is it not like flipped over the, oh, I flipped it over the wrong.
You flip it over both.
Well,
This B is just this area, Nicole, revolved around the x-axis.
oh, okay.
C is this area revolved around the y-axis. I just haven't drawn it yet.
I don't know if I drew C right, but I attempted.
Walter, no.
What?
I don't want no
Those
calculator
two, yeah.
being used right now.
I'm not using calculator, I'm just saying, it would be helpful to not always simplify with the exponent because,
Oh, I see.
yeah, I'm not like, I'm actually giving like good advice here.
I
He's
see.
like, how did you just have the equation? Oh, god dang it.
Wow.
Kiri.
Dang it.
Whoa!
Whoa.
Oh, snap.
Not as bad.
Which
Not as bad as what I said.
I heard dang it and then a bunch of O's.
Miss Young walks in and is like, Megan!
Oh, that was so funny.
Oh, we will not repeat.
What did Megan
That
say?
incident?
Megan
The
said.
F word.
Did she?
Whoa, the full F word, like hard
fudge?
Okay, well, the window was open and I was
Yeah.
cold and I was
And she
like,
wasn't
"Who
aware that
opened
Miss Young was in the room.
And Miss Young was like,
Just
me! That's what happened.
Miss Lau is visiting class tomorrow. I'm very excited. And Monday.
All day.
She sits there with her like blue surface and
You
like.
cannot concentrate when there's someone else.
One time when she visited our calc class last year, she
Okay.
started asking questions.
Can we stay, can I, area shaded A?
Go from 0 to 2 of x to the 4th dx. The definite
What?
Okay,
integral.
that made, okay,
No, you
no.
Isn't this just like the,
definite integral.
From,
0 to 2
Of x to the 4th
dx.
okay.
Whoa.
That's all, I just wanted the integral expression. That's all I wanted. Okay.
Oh, it's just
You can remove an x to the 5th evaluated at 2 at 0.
what?
Which is 25 halves. No, 25 fifth. No, fifth, x to the 5th.
I don't know what you're doing.
32
When you
fifths.
make these sketches, it's very helpful to make a picture, like to draw a cross section. So as you're visualizing D, the cross section in B is what type of cross section?
Horizontal.
vertical?
No. They go this way.
Okay, they're stacked over an interval of X.
But they're
What shape
vertical.
are they?
Vertical
And so what are they, discs? Are they filled in circles?
Yeah.
They're
discs.
Circles. They're circles. Instead of washers.
What? Sorgles?
That's a bakery.
Yeah, I know what sorgles is.
Go put it up.
What's a
Oh, I'm talking about C. But I think
So
I
then-
do too.
Yeah,
so do you do the term?
And I'm going to draw, again, the critical body parts. You draw like the critical, the radii, draw it to the curve. Draw to the curve, not its image, okay? And then I'm gonna draw, let's see, do you agree, Jabril, tell me what shape is the cross section? How are they stacked?
Like a circular half pipe. Oh, wait, that's
Yeah.
Yeah, like a circular half pipe.
No, it's just a
A washer?
Like a
washer.
It's a washer.
Yeah, but wait a second, hold on a minute.
A circular half pipe.
No,
What's
not
that?
this
What's
way,
that?
Jabril.
Like
This
like
way.
it's like that,
Oh.
but like
Oh, I see. I know what he means, Megan. He's
Yeah.
saying it's like it's
Like
completely-
this way.
Like a bowl.
no.
It's a circular half
A
pipe.
bowl with a starting.
A half pipe.
Wait,
Isn't that a skateboarding thing?
Yeah.
How do you do that?
Slash snowboarding.
Shut up, Alton. Oh, I'm just stupid.
No, you're not stupid.
No, you're not.
Yes, you are.
Everyone Oliver, I like your socks.
Oh my god, they're pizza sauce.
Okay, can I have some, put that up?
Which, what?
Jason, go ahead.
I can put up.
Just like,
Jason,
You like
what I'd like to draw is draw the radii.
Ray,
C, I want the two radii,
I.
B and C.
Sorry to whoever is listening to the
Tomorrow.
screen caps.
Okay, here's an
Yeah,
option for you. I have an
honestly.
option for you. Would you like us to, because I think, here's my thought. I think tomorrow I want to have I want to do volumes involving cards. And then we'll move the quiz.
Card
How about
design.
that?
Yes,
Card.
yes, yes.
It's a
Card
Card
design.
design.
I thought you said carts. I was in like shopping
We
carts.
messed up letter C.
Because
No, we didn't.
For Miss Lau.
What way?
Oh, I have playing cards, but then
that, you know what I mean. Like I want to do practice.
Do like R1 minus R2.
We did like.
That's fine.
No, I was just asking this.
I thought I was two square.
Oh,
What
that's
is,
right over
what is
there.
your large radius? Large radius is
Large radius. Right, yes, this is like two.
so the large radius is a constant 2.
Flash.
That's the
Alright.
second one. Yeah.
Yeah, it's a constant.
So R2 is R2 the long one? Okay.
Indubitably.
Oh my god.
R1 is fourth root of y. That is correct. It is the fourth root of y.
An IKEA?
Heck, yeah.
Oh, whoa,
Oh.
whoa, whoa, whoa.
Can I get an
IKEA. IKEA used to like scare me.
IKEA. I get lost in IKEAs.
I got lost in Costco one time.
Here is the next step of this.
Wait, why is it, oh, never mind. I got it. I'm good.
Screencast.
Wait.
Other way around, Jason. Pi is larger. Oh, yes, you're right. Very good. Larger depth. So volume equals. Very good. Another root. Yes. Okay. Very good. Have a seat. Have
That's
a
just 4.
seat.
I said I wrote two before. Two.
You know
Oh,
that
yes,
this is
it's
where?
one.
Okay.
2 carat 4.
Okay. Okay. Look over here. Let's take a look. Ready?
Okay.
So, do we agree that we're looking at cross sections stacked vertically,
Oh.
everyone? Yes or no? In this case,
Oh.
cross sections stacked vertically.
Yes.
Okay.
I did 1/4.
Do we
square
then, if
is
the
more
cross
radius.
sections are stacked over an interval of y, then the dummy is y? Agreed. Yeah. Okay. Okay. We're gonna build. Let's make sure we build this integral correctly. We have the dummy is y. That means we have to say now what the limits of integration are. What are the interval of, so you always like put the dummy down first. That tells you everything else. The dummy is y because you're adding up cross sections stacked vertically. Dummy is y. The y values over which the cross sections are stacked are y equals 0 to y equals 16. Okay? So once again, dummy is dy, 0 to 16. Everyone okay? Then you look inside the outer radius, the large radius. If you look at this particular solid, the large radius is always 2. Always 2. It's always the larger, the y-axis to 2. Any questions? I need to, are you, everyone okay? Are you okay over there? Got that? The inner radius is going to the curve y equals x to the 4th. Most people would write the inner radius is x to the 4th, but your dummy is y. So you have to rewrite y equals x to the 4th as x equals the 4th root of y. Don't forget to then square your radii. Okay? Okay. Okay, in the interest of time, we haven't done B. May I just throw it up here so you can see it?
Yeah.
Okay, this volume here is going to be the definite integral from 0 to 2 of pi x to the 8th dx.
White.
Okay? All right. Okay, so here, I'm gonna make a declarative decision. No quiz tomorrow. I want to shake things up tomorrow, making sure we're really comfortable going back and forth with all of these.
Shake things.
Yeah, we're good, So I will, let's off